Okay, so in this section, we are repeating the whole idea of tangent and normal, but we will be using together with differentiation of trigo and differentiation of ln and exponential. So sometimes there's a bit of mind block when we repeat everything. Okay, so the steps doesn't change. So if you still remember for tangents, right, there are 3 steps. First step is to get dy dx. Second step is to put in the x so that you can get the value of m. And then the third step, you got to use a coordinate. They will have given you a coordinate. So you do a coordinate, use the coordinate and m to do a mx plus c. So that will be the 3 steps that previously we have done. So for the normal, we got 4 steps. So first thing is still your dy dx. Second, you put in your x. When you put in your x, you get the gradient of tangent. So third step, you got to use this formula to find the gradient of normal. So that will be the m. Then lastly, then you do the mx plus c. So between tangent and normal, tangent got 3 steps, normal got 4 steps. So it doesn't change if you have a different kind of dy dx. So like for example, if you look at A1, it's just finding the equation of tangent and normal to the curve at the 1 point. Okay, so that means, right, I need the equation of tangent and I also need the equation of normal. So the first thing I will do, both first step are common. I must find a dy dx first. So that will be my first step. Okay, then if you look at the steps, second step, I'm supposed to put in the x. Okay, no, sorry. This step, I'm finding the coordinate first. So this step, I'm finding the coordinate. So this one is not my second step. Okay, because they only gave me x coordinate, I don't have the y coordinate. So I decided I'm going to find the y coordinate first. So this part is not the step 2. For step 2, your job is to put the x into dy dx. So if you take a look at what I have done, your job is to put the x into dy dx. Okay, one thing you need to take note. You need to do it in radian mode. So this part, when you put into calculator, your calculator has to be in radian mode, or else your values will be wrong. Okay, and why do I get a √3/2? Actually, this is under the special angles. Special angles in trigo. So there are 3 special angles: 30 degree, 45 degree, and 60 degree. If you've forgotten on this, there's a video on the special angle. So anyway, when I press calculator, cosine pi over 6, you will not get a √3/2. You will actually get 0.866 something. But you go and square the whole thing, you will get a 3/4. So from the 3/4, you take the square roots. So I throw the square roots over. So that's how I gotten the √3/2. So I'm still currently at the second stage. But at the second stage, because of the special angle, you will see some ugly numbers. And if you forget special angle, you'll find that, hey, how come my gradient is like this? Okay, so in this case, right, this is the gradient of normal tangent. So that means this is the m. This is the m that I can use for the gradient of tangent. So I do a mx plus c. And how can I find the c? That's why I got to use the coordinate here. I put in the coordinate to get the c. So this is the third step of finding the equation of tangent. So can you see it's 1, 2, 3, 3 steps. So I'm going to repeat it for the equation of tangent. For the equation of tangent, step 1 is the same, step 2 is the same, but then I got to make use of the m1 times m2 equal to -1 in the third step. So the gradient of tangent is √3. That's why you got to do this, use the perpendicular formula. So that's how I get the gradient of normal. So that will be my m. And I'm going to put back the same coordinate. And then I can solve it in mx plus c. So literally, you're just repeating the steps. So step 1, step 2, step 3, step 4. Try to follow the steps. Okay, it's just that right now, because it's in trigo, you got to do it in radian mode. And because it's in trigo, you can see some ugly numbers. Okay, so the second one is going to be the same thing. The second one, I got a y, then a y in terms of ln. Then I'm supposed to find the x coordinate. So my job is to find the x coordinate. Where the normal is perpendicular to the line. So I need to do my steps about the normal first. The normal got 4 steps. So first step, I'm going to get my dy dx first. So in any case, if you forgot how do you get your dy dx, right? Which formula am I using? I'm using the formula 1 over fx, and then you got to differentiate fx. So that's my first step in the normal, in getting the equation of normal. Okay, then because they mentioned about the line, I got to think about the line first. So I already had my first step of equation of normal. Okay, let me think about the line first. So how am I going to think about the line? So I'm going to think about the line by making mx plus c so that I can tell the gradient of the line. So that's how I process the thinking. So the question is saying that the normal is perpendicular to the line. So the gradient of normal times the gradient of the line should be equal to -1. So that's what the question is telling me. So I already got the gradient of the line. So because of this, I can get the gradient of normal. So that's how I got the gradient of normal. And then we logic out a little bit first. We also know that there is a relationship between tangent and normal. So that is a generic relationship. So this part here is based on what the info that the question gave me. But I do know that tangent is always perpendicular to normal. So right now my normal is -3. So if I can get a 1/3. Okay, why am I interested to get the 1/3? Because gradient of tangent is dy dx. And that's how I can use my dy dx and solve for the x. Okay, I do not need to complete all the 4 steps of the normal because I'm not asked to find the equation of the normal. But I still go through the steps. And along the way, if you think about the process, think about the line, think about the gradient property, it will lead you to a dy dx equal to 1/3. Okay. Okay, the last one here, I got 2 things to find. They gave me an equation. They gave me the curve meet a straight line at A. And I'm supposed to find the coordinates. So I'm supposed to find the coordinates. and I'm supposed to find the equation of normal. So equation of normal, that means this one, I need the 4 steps. Okay, so right now I'm going to do the first step. My first step is dy dx. So which formula am I using? I'm using the EFX. Differentiate EFX with EFX, and you differentiate the power. So that's exactly how I get my first step. Okay, so after I get my first step, okay, let me focus on finding the coordinates of A first. So to find the coordinates of A, when a curve meets a line, it's an intersection. So that's why I'm doing a simultaneous equation. So the simultaneous equation need you to remember the steps of taking ln both sides. So this is under logarithm. So if you forgot this part, there is a video to emphasize on this part. So I take ln both sides. The ln will enable me to bring down the power. And that's how I get the y coordinate. So this whole part is dedicated to finding the coordinates of A. Then now I can continue my equation of normal. Okay, so the first step of dy dx is done. I continue with my second step. I put in the x into dy dx. This is the gradient of normal. Sorry, that's the gradient of tangent. So you've got to get the gradient of normal first, perform this formula, and I will get a -2. So that will be my m, that I will do the mx plus c. Okay, I got the coordinates already. So I'm using 1, 1 to find the c. So can you see I'm repeating the 4 steps? So my working is still, I still stick to my working. 4 steps for the equation of normal, 3 steps for the equation of tangent. Okay, so you have to be very systematic, and the differentiation is just a bit different, not the usual product rule or whatever. So don't let that get you down. The steps of tangent normal cannot change. Okay, so only in the trigo part you need to remember about using it in radian mode. If you do forget, it will actually cause a calculation error. Okay, so that is the equation of tangent. Like to revise using further differentiation technique, trigo, exponential, and more.